let's find some inverses. Inverses? Inverses. Is it still on your hand?
Yeah.
Okay.
Look.
Here's the process we go to. If the function has an f of x, change it to y. Because f of x and y are basically the same thing.
Yeah.
Switch all of the x's to y's and all of the y's to x's.
Right.
Solve for y.
Right.
And then replace y with this notation,
Right.
which simply means the inverse of f.
Yeah,
that's what f to the negative 1 means.
Yeah, that's all you do. It's not hard, but the teenage brain messes up these 4 very simple steps. I don't know. I'm not sure why.
I don't know
I think
either.
because you really want to make inverse super hard, and it's not.
It's not. Okay. The hardest part of it is sometimes the algebra gets a little tricky.
I'll give you that part.
Okay.
But changing out x's and y's,
That shouldn't be
not hard.
So find an equation for the inverse of x if the inverse of f, if f is this, and then we're going to give the domain, and we'll talk about that in a second. So where f of x is, I want to put y.
Right.
Here's my function.
X over x plus 1.
And now,
Okay, so we're looking at it this way.
and now we're going to swap.
Now we're going to swap it, and we're going to look at it this way.
Now this actually, I picked one that's pretty difficult to solve for
You did.
y.
This is a toughie to start with, but
A lot of times you'll start with like y equals 6x, and you switch the x and the y around. And then
solve for
I
y.
just have to
There you
divide
go.
by 6.
Bingo.
And then there's your inverse.
Right.
That's simple.
But think
That's not
about
what
this,
I
though. This is a toughie, but what
Okay.
we want to do is we want to get all the y's into the numerator
Okay.
and on the same side of the equal sign.
Well, numerator means I need to multiply both sides
That's
by y plus 1
correctamundo.
over 1. Because that cancels that out.
There you go.
Now that's a parentheses situation on this side.
Right.
Okay. Now this is where people get hung up because you think distributing would be counterproductive, but it's not.
No,
Go ahead and distribute.
If you divide by y plus 1, you're back where you started. So we
Right.
don't want to do that.
Get your y's on the same side, which means I have to subtract xy. So x equals y minus xy. Now the things on the right have something in common. They have a y in common.
Right. So now you just factor y out. So
you write down what they have in common.
right.
And
And
then,
then what's left? 1 minus x.
and that 1 is because it had a y, we took it out, so we got to put a placeholder.
Right.
Took this y out, so minus x.
Right.
Now we can divide by 1 minus
Right.
x, and y will be by itself.
Yes. Now, would you write that up there next to the purple one? Yes, right there.
Should I write y?
F negative 1. Whatever you want to write there, Mrs. Casey.
Squiggle f negative 1 of x equals x over x minus 1.
Okay, now
Those are super
that's
similar.
1 minus x, not x minus 1.
Oopsies.
Now, here's the thing that I wanted to point out.
Okay.
The inverse does not mean making everything that was in purple minus
Right.
and just rewriting it.
Right.
Because
It's a little bit
there's
more
more to
complicated
it's a
than
little
that.
more complicated to that. Yeah.
Because this was a positive 1, this is a positive 1.
Right.
This was a positive x, this is a negative x. But
The x on the positive
crazy
is but
things
it's
can happen.
yeah, it's weird stuff. So
You got to go through the process.
yeah, when you're inversing, you can't just go through and slap negatives on stuff. You've got to go through, set up, solve out, and get your
Right.
correct function.
Absolutely right. Okay, so we said what our x and y normally are switches and now becomes
Right.
this away, which means that the domain of our original function
Brings in a restriction.
becomes the range of our inverse.
Whoa.
Because the domain is the set of x values
Mind blown.
and it switches and becomes
So
our
you're
set of
going to
y
say
values.
some silly thing like the range becomes the domain of the
That's
inverse.
exactly what I'm going to say.
Unbelievable.
So what you do when you find the domain of your inverse is you don't find the domain of your inverse, find the range of your original function.
There you go.
Because sometimes in our process of simplifying, we won't end up with all of the correct
Right.
restrictions. But that's what this means when it says give the domain of the inverse, including any restrictions inherited from f.
That's like getting gray hair when you're 30 or something. You've inherited that from like your grandpa.
Yeah, totally. So the range of f, stick that in your calculator. I was sure there'd be a calculator in there.
There's one right there. Look, you touched like 3. This one's not.
Oh, there's one. I found it.
know why that was so hard for you
So
to see.
type it in, x
But am I
divided
typing
by,
this one?
no,
This
the,
one?
the original.
Okay.
So we're going to look at the range.
All right. Original.
X over x plus 1. And I'm going to guess, oh, I guess I do know what the range is. That looks like 1 is our value. Is that right? Our horizontal asymptote
I believe
is at
so.
1.
Yep.
And so that means that our range goes from negative infinity to 1, and from 1 to infinity.
Right.
And so that is what our domain
Of the inverse
of
will
the
be.
inverse is, yeah. Is that right there. Now, in this particular case, if we had just looked at the domain of the inverse, we would have gotten that.
Right.
But that's not always the case.
It won't always happen that way.
Okay, you
That's
always
correct.
have to check the range, and mainly when you look at the domain of this, if you had gotten all real numbers, go back and check the range on the first function.